Hello, friends. Welcome, welcome to the next video in our arithmetic series. Now, this is all about simple interest and compound interest. Yes, the same topic which you have done already in your school days, but let's revisit and learn all the things about it. Yeah, okay. So, friends, as you know, the importance of this topic, not just from this exam point of view. Yeah, this is also very important to understand and learn from your real life point of view. You will be dealing with this quite often. Whenever you're investing something, whenever you're taking some loan, everywhere the word interest matters a lot. Correct? So you should have good enough interest in learning this. All right. So, so basically, ultimately, what is interest? The returns you get on your investment. Yeah, the extra money apart from whatever you invest, or the extra money or amount you pay on your loan, and all this is happening because of time value of money. Yeah, so you all know what is this time value of money. Yeah, so all right, let's go ahead. So first you should know the common terms which you'll be using in this topic throughout. So I will be nothing but your interest. A is amount. Amount is nothing but the original money borrowed. That is your principal plus the interest generated. So this is amount. Okay. N is number of years. So amount was principal plus interest. Always. Cool. R is rate of interest. Generally, rate of interest is given in terms of per annum. That is per year. Per annum means per year. Simple interest. The formula, if you see, is PNR by 100. In compound interest, we first find the amount. This is the formula, P into 1 plus R by 100 raised to N. And N is not just number of years the way it is in simple interest. It is number of time periods, simply because there are various ways in which compound interest is calculated. That is mainly annually, that is after every 12 months, or half yearly after every 6 months, yeah, or quarterly after every 3 months, like that. Okay, get it? So note these common terms. Let's explore this simple interest. So ultimately, the main funda of simple interest is fixed interest every year. Let's understand this in a diagrammatic manner before we go ahead and explore in terms of numbers. Yeah. So suppose this is your principal, initial money which you have invested or which you have borrowed. Then some percent of that P will be the interest. Okay. Got it? So that is R% of your principal, this much. All right. Next year, also the money will grow by the same amount, same value. See, this height is exactly same. So that extra money is nothing but R% of original principal only. And you know, original principal remains same. That doesn't change. So how will this change? So this will also not change, right? So every year it will grow by that R% of P only. Every year. Correct? So in n such years, it will be n times R% of that P. Correct? And that is how we write n times R upon 100 into P. So P and R upon 100. So this becomes the formula for simple interest. All right, friends. Okay. And amount is principal plus interest. In first year, P plus R% of P. In second year, P plus 2R% of P. In third year, yeah, means after third year, P plus 3R% of P, and so on. This is a simple logic. There's a linear growth. So amount changes linearly. The difference remains same. You can also see, if you know, there will be like a arithmetic progression happening. Fixed value will be added every year. Only a fixed number. Let's say 100 rupees is the interest, simple interest. So every year plus 100 plus 100 plus 100 plus 100. Okay, got it? All right. I hope you have noted it. You can pause the video, keep noting, keep making your notes. All right. Okay. Now, Let's understand this through numbers. Very easy. Let's take some easy numbers. Suppose principal is 1,000 rupees, rate of interest is 10%. Yeah. So we are taking the principal as 1,000 rupees and rate of interest as 10% per annum. So first year, yes, interest will be 100 rupees. Second year also, interest will be 100 only. Why? Simply because 1,000 rupees is not changing. So I am keeping my principal fixed as my old original principal 1,000 rupees. All right. So every year it will be 1,000 rupees only. If the base is only not changing, why will the interest change? So every year fixed interest, that is 100 rupees. All right, friends. So in 5 years, if you see, total interest is 500 rupees and total amount. So principal was 1,000 plus 500 rupees interest. So ultimately 1,500 rupees. Cool. Okay. Got it? Understood? Okay. Now let's see compound interest. Actually, in simple interest, if you see, friends, the interest which was generated after first year, that was your 100 rupees. Technically speaking, if you're not returning that money, so you are using that money also, right, for next 1 year. So ideally, you should pay some interest on that 100 rupees also, isn't it? That was a simple reason because of which, in our daily life, simple interest is not common. So whenever you invest something, you expect in return you should get compound interest only, like your FDs and all. And whenever you take loan, banks will also charge compound interest only from you, not simple interest. Otherwise, everybody would have taken such big loans and build palaces. Yeah, okay. Let's go ahead. Now, let's first understand diagrammatically the main thought, the main funda. So this is your initial principle. Yeah. In year one, the amount will be old principal P plus R% of that P. So this much is the growth. So if you remember, in first year, the simple interest and the compound interest, both of them remain same. Simply because for both, the base is original principal only. Okay. Let's see what happens in year two. If you remember why this funda is introduced, because this interest was not earning any interest in case of simple interest, but now we're including it in the calculation of the next year's principal. So next year's principal will be previous year's amount. Yes, this full thing is going to be next year's principal. So R% will be applied on not P. So R% will be applied on this A1. So A1 was your P plus R% of P. So P common 1 plus R by 100. Remember old value, new value logic. 1 plus base fraction in percentages. We had done this exactly the same thing. Only the wordings are changing. In place of new value, we have amount. In place of old value, we have principal. Yeah, that was the logic, right? In percentage we have studied. So new value is old value into 1 plus base fraction, 1 minus base fraction. Remember that funda. A is height, B is height, all those things. Remember example? Okay. Now, so in year two, did you see the amount to A2 is this black plus the black is nothing but A1 plus R% of A1, not R% of P. You can see the height of this is more than this. More interest every year simply because previous year's interest is also included while calculating the next year's interest. Yes, so A2 is equal to A1 plus R% of A1. So A1 was this. This plus R% of this, if you take common and simplify, ultimately you'll get this. In short, see, the this number got multiplied by 1 plus R by 100. So it became 1 plus R by 100 the whole square. So every time, if you see, the power will increase. So if I have a number, let's say 3, then 3 square, then 3 cube, then 3 raised to 4. So what is happening, friends? Can you see? This into 3 will give me this. This into 3 will give me this. This into 3 will give me this. So multiplying factor is remaining the same, remaining constant. Such sequences are called as geometric progressions, if you remember. And if I have 2 plus 2, 5, 8, 11, and so on, this was your arithmetic progression, right, friends? The difference is same, plus 3, plus 3, plus 3. That is the logic of simple interest. And here in compound interest, you will see that it is like a geometric progression. Every time you're multiplying by 1 plus r by 100. Yeah, so next year, year 3, see, A2 will continue. A2 will continue plus r% of that A2. Again, bigger height, increased interest every year. Yeah. So after simplification, you see P into 1 plus r by 3, 1 plus r by 100 raised to 3. And finally, year 4, A3 will continue and r% of A3 extra. See the growth, phenomenon growth. That is why, when you go to world of finance, the first thing they teach you is this only, power of compounding. You must have heard this term in finance world, power of compounding. See how the money is growing. It is growing exponentially. So in general, the formula becomes, yeah, an is equal to p into 1 plus r by 100 raised to n. N is nothing but number of times you are doing the compounding, correct? So if you join all the values, see how it is increasing exponentially, or can say geometrically. And here the ratio is same, next year's amount upon previous year's amount. Every time the number, the value will be 1 plus r by 100. Okay, got it? Yeah, time period 1, 2, 3, 4. So n is number of time periods or number of compounding. Number of times you are performing this compounding means number of times you are doing the calculation of the interest. Okay, got it? Let's go ahead, friends. I hope the base is getting clearer now. Curiosity is getting built more and more. Okay, what next? What next? Now it's time to learn through numbers, the main thing. First, you understood the theme through that diagrammatic representation. Now, actual calculation. So I'm taking the same set of numbers, principal 1,000 rupees, interest 100 rupees. How? Rate of interest we have decided is 10%. Okay. So first year principal 1,000, interest 100 rupees. Next year, remember the principal will change. How? Old interest will also be added. So 1,000 plus 100, 1,100. This is the difference between compound interest and simple interest. So on 1,100, if I calculate 10%, of course, it will be 110. In simple interest, second year's interest was 100 rupees. But in compound interest, it is 110. Did you see? You're getting 10 rupees extra. Logically, what is that 10 rupees? Nothing but 10% of this 100. So you included 100 in your calculation, right? So 10% of that also will come into picture. And that 10 rupees only we call it as interest on interest. Hence the name compound interest. All right. So basically, compound interest and simple interest is all about common sense. We are developing that common sense now. Okay. Again, same funda. Next year's principal will be old principal plus old interest. So 1,100 plus 110, 1210, 10%. So 121. Same funda again. Next year's principal will be old principal plus old interest. So 1331, 10% of that. Finding 10% of any number is going to be absolutely easy, right, friends? Just put a decimal before the last digit. Before the last digit. So 133.1. Yeah. Same funda. Keep continuing. 1464.1. So 146.41 will be the 10%. If you add all of this, the total amount is 1610.51. Yeah, that is you added all the interests and plus 1,000 original principal. Clear? Now, one more way of looking at it. The first one, if you see your principal is getting multiplied by a fixed number 11 by 10. So 1000 into 11 by 10 is 1100 into 11 by 10 is 1210 into 11 by 10 is 1331 into 11 by 10 is 1464.1. So this is that multiplying factor which is remaining constant every time. So geometric progression is happening. GP. Okay, 1 plus base fraction is that number. Remember? Yeah. New value is 1 plus base fraction times old value. This is very smart logic. If you understand this, a lot of tricky questions you can solve comfortably without actually depending upon any particular formula as such. So interest in any year is interest of the previous year plus interest on that interest. Check. So this 110, the way we had discussed, is nothing but 100 rupees, the previous year's interest, plus whatever the rate is 10%. So 10% of that 100, isn't it? So this is 10. Yeah, this component was missing in case of simple interest. So this is going to be the difference between compound interest and simple interest. Okay. Similarly, if you analyze 121, what is 121? Previous year's interest 110 plus 10% on that 110. So 10% on 110 is 11, isn't it? Yes. Just continue the same logic further. So 133.1, how we are getting it? Come on, friends. Yes, 121 plus 10% of 121. And 10% of 121 is 12.1, right? Cool. Same way, 133.1 plus 10% of that, which is 13.31. If we add it, it is 146.41. Get this logic very clearly. This is very, very helpful in solving the questions logically. Okay. All right. So total interest and then amount, Yeah. This is also very, very important, friends. Please note it very carefully. Cool. One more way. Uh, Successive percentage change. If you remember in the last topic, we have done it, that A plus B plus AB by 100. Yes. So first 2 years, if you see effectively, totally it is giving us A plus B plus AB by 100. So 10 plus 10 plus 10 into 10 by 100. So ultimately 21%. What is 21% of 1000? 210, right? 210. And you can verify. See, first year's interest is 100 rupees. Second year's interest is 110 rupees. So total 210 rupees. Simple, isn't it? Successive percentage change. So in compound interest, this logic is going to be used a lot. That effective rate of interest for some time periods is nothing but the successive addition of all those. In simple interest, it will be flat addition. 10%, 10% for 2 years will be 20%. 100 plus 100, 200. Remember, in simple interest. But in compound interest, it will be successive addition. Let's check for 3 years. Yeah, so take the third term, again apply successive A plus B plus AB by 100. So this calculation will be 33.1%, and 33.1% of 1000, yes, is going to be 331. And you can check 100 plus 110 plus 121. Same way, keep continuing. Yeah. So this, if you apply A plus B logic, so ultimately 46.41%, which is 464.1 addition of these 4 years interest. Cool? Comfortable? All right. All right. Then finally, the last year, 5th year. So if I apply successive, so ultimately I am going to get 61.051% of 1000. So 610.51, which is addition of all these 5 years interest. Superb logic, right, friends? This is the compound interest. I hope this should give you a lot of clarity, no tension, full confidence. Okay. Yeah. Sorted. Okay. So both the numbers in front of you in one table, friends. both the calculations, simple interest, compound interest. Okay, you can see first year both are same. Yeah, second year compound interest is taking a lead because that interest got generated, which will also earn interest. Then so there is no stopping. Yeah, interest on interest, interest on interest will keep getting added. Correct. And summarizing one more thing. So basically, in case of simple interest, it was flat 10%, and in compound interest, flat 10% first year. Second year also simple interest will be 10% only, right? But compound interest was 11% because 110 was the interest, which is 11% of 1,000. So effectively, in 2 year, total simple interest was 200. In terms of percentage, it is 20%. Flat addition. Remember, it remains same every year. But compound interest was 210, which is effectively 21%. And how did we get that? Yes, successive percentage change. 10 plus 10 plus 10 into 10 upon 100. Got it? Clear? Okay. This table, these examples, you should remember properly as your reference point. Yeah, you can always relate to them when solving the questions. So let's take one question. The difference between SI and CI for the first 2 years is 34 rupees, and the total simple interest earned in this period is 1,360. So find two things, the rate of interest and principal. You can pause the video, you can try yourself and then come back to it. Yeah, how will you try? Let's start. I hope you have done it. The best start here would have been your total SI. So you can easily break it down now. For 2 years, it is 1,360. So every year divide by 2 because it remains same every year. 1,360 divided by 2 is 680. So first year simple interest 680, second year also same. Now what did this do for me? I came to know first year's compound interest, which is 680 only because in first year both of them remain same. This was the thought process, friends. This was the thought process. The next year 680 will continue plus interest on interest, and that is only the difference between the simple and compound interest for the first 2 years, right? Interest on interest. This 34 rupees was the differentiating factor. So 34 rupees extra was given by some logic, by some rate, by some calculations that we can find now that 34 is achieved at what percent of 680. So 34 is what percent of 680? Is what percent of 680? I'm just writing in detail for the first time. So 34 is equal to x upon 100 into 680. So basically 34 upon 680 is equal to x percent. Yes. And your x is nothing but r, rate of interest, right? So 34 upon 680 into 100. Next step of this. Correct? And 10% was 68, half of that. So 5% is 34. Correct. So we got rate of interest. And once we have rate of interest, it's over, right? So this value is 5%. So 5% of some principal is 680. Yeah. I is 1. In 1 year, simple interest was 680. So P into 1 into 5 by 100, solve, you get 13,600. So principal is 13,600. One more way was, this is 5%. This is also 5%. So 2 years simple interest is effectively 10%. That we know already, 1360. So 10, this is logical, huh? 10% of principal is 1,360. So 10% of something, and you want to find 100% of that thing. So just multiply by 10, right? So 1360 into 10. So this is your principal. I hope you understood this example. Very, very nice example to understand and strengthen the concepts further. Okay. All right. One more. The difference between the SICI for the first 2 years, now in terms of percentage is given. At 20% per annum is 32. Find principal, total SI, total CI. Again, pause the video, try, and then come back. Okay, friends, you must have got it now. Chalo. First, that reference point. Remember that reference table, which we have studied in terms of concepts. So 2 years simple interest was 20%, 2 years compound interest was 21%. How did we get this? Successive percentage change, isn't it? Correct. Let's do the same thing here. Here rate is 20% instead of 10. So 2 years simple interest will be 20 plus 20 flat addition, that is 40%. What will be 2 years compound interest? Correct. There you are. Successive percentage change. So A plus B plus AB by 100. So 20 plus 20 plus 20 into 20 by 100. So 40 plus 4, 44%. That's it. So what is the difference? Correct. 4%, isn't it? So 4% of some principal is 32. So if 4% of something is 32, so what is that 100% of that thing? You can do it like this also, school method. 4% of some principal is 32. So 4 8s are 32. So 8 into 100. So principal is 800. Or 4% is 32. So what is 100%? So into 25. 25 times. Yeah. So we got the principal. That is 800. Total SI was 40%. So 40% of 800. 10% is 80 into 4. So 320. Yeah. And compound interest is 44% of that. Don't find again. You know the difference is 32. Be smart. So compound interest is 32 more. So 320 plus 32. Correct. 352. Got it, champions? Yes, friends. Understood clearly? Yeah. Good one. Let's go ahead. Okay. Next thing is like understanding multiplicity of principle. For example, you must have heard na paisa double ho gaya, paisa triple ho gaya, 25 mein paisa double, something like that. So here, suppose money tripled. So your 100 rupees investment, for example, became 300 rupees. What does that mean? That interest given to you was 200 rupees. Okay. So interest was 200, principal was 100. So don't you feel it is 200% of 100? Yes. Suppose money became 4 times. So 100 became 400. So 300 was the interest given to you, right? So interest was 300% of the principal. Amount was 400% of principal. So interest is 300% of principal. Extra, na? So let's generalize this. So amount becomes n times principal. So interest will be what? N minus 1 times 100%. Yeah. Correct. So when amount was 4 times, interest was 300%. So 4 minus 1, 3 into 100. When amount was triple, so 3 times. So 3 minus 1, 2 into 100. So 200%, like that. Yeah. This is like a general thought. I'll take some numbers also later on. Don't worry. So basically, amount changes linearly. You know this very well in case of simple interest. So interest is directly proportional to number of years. More the number of years, more is the interest. But it remains same every year. Hence, it is linearly. Okay. So if the principal becomes n times in capital N years, so ultimately interest is this minus 1 into 100% of principal in those n years. Just now we saw, right? 200%, 300%. Yeah. Suppose specifically, so R becomes what? This is in n years, right? So per year or per annum divide by n. So for n years, this is the logic. So for 1 year, divide by n. Correct? Simple. All right. Specifically for doubling, if money doubles, the small n is 2. So if you put this as 2, so 2 minus 1, 1 into 100 divided by n. So if it doubles in 5 years, so rate of interest is what? 100 by 5, 20%. If it doubles in 10 years, 100 divided by 10, so 10%. Okay. Got it? All right. Now, in case of compound interest, you know, yeah, amount changes geometrically. That funda was in geometric progression. Remember, into 1 plus r by 100 and in numbers of that table into 1 plus 1 by 10. So into 11 by 10 ho raha tha bar bar. Yes. Amount undergoes fixed multiplication in fixed time period. Yeah. Specifically for doubling, if you talk about doubling, this should be actually approximately. So rate of interest is approximately 72 by n. This you should remember, but this is specifically for doubling, huh? So suppose your money doubles in 8 years. So rate of interest will be roughly 72 by 8, that is around 9%. So closest we can go is up to 9%. Actual answer will be slightly above 9%. Yeah. But this logic is for doubling. Okay. Yeah. Rule of 72, that is what they call it in real life, in world of finance. You must have heard it. Okay. Got it? Please note these things down. All right. Now see the example. If an amount kept at SI doubles in 3 years, then in how many years will it become 10 times? Simple logic. Doubles in 3 years means if you keep 1 rupee, it became 2 rupees in 3 years. So this was your principal, this is your amount. Correct? So what is the simple interest earned? 2 minus 1, that is 1 rupee. Now they want this 1 rupee to become 10 rupees. So what should be the interest earned for this? Yes, 10 minus 1, 9 rupees. You know that 1 rupee you earned in 3 years. So by the same logic, 9 rupees you can earn in how many years? Yes, 27 years. Correct? Simple logic. This is how we should do it. No formula, nothing. Okay? Understood? Next question is about compound interest. If an amount kept at CI doubles in 3 years, then in how many years will it become 8 times? So it is perfect power of 2. So 2 times in 3 years, 8 times means 2 cube times. Then we can afford to solve. So 1 rupee becomes 2 rupees in 3 years. By the same logic, friends, 2 rupees will double, na? That it will become 4 times 4 rupees in next 3 years. So doubling happens every 3 years. So 4 rupees will double, that is 8 rupees in next 3 years. When you don't withdraw all this money, it will keep doubling. 8 rupees will become 16 rupees in the next 3 years. So for 1 rupee to become 8 rupees, 3 plus 3 plus 3, 9 years, right? Understood logically. Since it is about doubling, we can also find rate of interest approximately 72 by 3. So rate of interest will be close to 24% per annum. All right. Understood? Yes, friends. Cool. Now, one last thing, that is different time periods of compounding. Remember in the beginning, we had discussed compound interest can be calculated annually, half yearly, quarterly, all those things. Let's understand through this example. A sum of 10,000 rupees, that is your principal, is kept at 40% per annum. So rate is 40% compound interest. Find the total interest earned and the total amount accrued at the end of 1 year if the compounding takes place in 3 ways: annually, half yearly, quarterly. All right. First thing, this basic information should know. So in annual, it will be done only once, right? So n will be 1. In half yearly, that is after every 6 months. So it will be done twice, but at 20%. So in annually, it was done at 40%. In half yearly, 2 times, but at 20%. Huh? I hope you're not feeling that 2 times 20% is going to be 40% only now. No. In the first 6 months, 20% interest got generated, which will be added to the principal. So the next 6 months, principal has increased. It is not same as the old principal, friends. Yes, I'll show you how much you're earning. Just stay tuned. Some of you must have got already in quarterly after every 3 months. So it will happen 4 times, but at the rate of 10% per annum. Correct. Yeah. So rate was divided by 4 in quarterly, rate was divided by 2 in half yearly, that is in monthly, it will be divided by 12, like that. So chalo. In annual, simple, 40% flat of 10,000, so 4,000 rupees. Amount will be 14,000, right? 10,000 plus 4,000. In half yearly, 2020. So effectively successive. याद आ रहा है net निकालना है तो successive ना. So A plus B plus AB by 100. So 44%. So interest will be 44% of the principal. So 44% of 10,000. So 4,400. ज़्यादा मिला ना? Yes. Amount will be 14,400. Quarterly, 10, 10, 10, 4 times. So first two will give you what? Up to by heart ho jana chahiye. 10 and 10 standard number, 21, right? These two will also give you 21 logically. Let's combine again. So in successive, you can take two terms only na, at a time. a plus b plus b by 100, इसलिए दो दो लेके करने का, एक साथ नहीं होता है. a plus b plus ab by 100. Yes, 46.41% effectively. Correct? Yes. So 46.41% of 10,000. 4641. This is the interest generated. कितना ज्यादा हो रहा है देख रहे हो? The more you compound, the more number of times you do the compounding, of course, more number of times interest will be generated, which will be added to the principal. So पैसा तो बढ़ने ही वाला है ना? Common sense. So amount will be what? 10,000 plus is 4641. So 14,4641. It is 641, huh, friends? So 14,641. All right. Understood? Yeah. At least these three ways: annually, half yearly, and quarterly. All right. Okay. And now sometimes they purposely don't mention specifically. So if nothing is mentioned about the time period of compounding, it is always annual, right? Assume it to be annual. Of course. So for half yearly, quarterly, they'll have to mention it specifically. Now, in the questions, if only one interest is given, they have not specified clearly, then it is simple interest. You can assume simple interest, but interest is given by bank, then it should be assumed as compound interest. Okay, got it? Understood? Great. So thank you so much. I hope now finally everybody is very, very clear with simple interest, compound interest. Yeah. So at the end of the video, you should have good enough confidence about the concepts of simple interest, compound interest, what are they, how to calculate, what are the formula, what is the logic, everything. So I'm sure I'm very, very clear that this must have helped you. So I hope you have taken the notes also properly. Yeah. So thank you so much for giving your valuable time to watch this before the session. So take care. Thank you so much. Stay safe. Stay focused. Bye.